Alright, this is a fairly complicated circuit problem, about as difficult as they get. Essentially, we're going to analyze this entire circuit. We're going to figure out everything about every one of the resistors. And so, it's going to be pretty complicated. It's going to be kind of a long one, so bear with me. Here's our circuit, 9 volts. Yeah, 9 volts. 5, 10, 5, 10, 10, 5, and 5 as our resistors. And I'm going to label them because I like to be able to keep track of them. So we got A, B, C, D, E, F, and G. Alright, now before I start, I'm going to write down a lot of things that I know. First is that I total is equal to IA. Alright, because all the current through the entire circuit has to go through IA. It's also equal to IG. Again, everything equal to. And that's also equal to IB plus IC plus IE. That's not all we could write down. We could do a couple more of those, but that's most of the generalized things. Okay? And the reason it has to be true is because any current that comes through this wire then has to go through either B, C, or E. It doesn't have a choice. We can also write down that IE equals IF and that ID equals IB plus IC for similar reasons. Anything through E has to go through F, B and C recombine and go through D. Alright, and that's all. There's more we could write down. We could like rearrange, but again, let's just give ourselves a kind of idea of what's going on. So then we have voltage identities. VB equals VC. And voltage has to follow the same amount, so it's going to start out the same, and it's going to end at the same. Okay? We also know that VB plus VD equals VE plus VF. Okay? Starts here, ends here. Either pathway has to give the same. We could also say that VC and VD are the same. We already know that because V and C are the same here. Alright, and finally, we know that V total is equal to VA plus VE plus VF plus VG. Okay, and that's just because it's got to go here and back to here. We know the difference there is 9. Finally, we know one last thing. We know that V total equals I total plus or times R total. Now we know V total, it's 9. We do not, however, know I total and R total. So this is typically we're going to start with a big problem like this. You're going to find R total. Okay, I'm going to do this quickly because there's another video about how to find equivalent resistance. So we're going to go pretty quick here. First off, I'm going to combine B and C. Alright, and they're going to give me 3.33. Okay? Then R, B, C, D is going to equal 13.33. So it's going to be because B and C are in series with D, so we add them together. We then know that R, B, C, D, E, F is going to be 1 over 13.33 plus 1 over 15. And again, the reason I'm using 15 there is because I know these two together are 10 and 5, or 15 together. And that should give us 7.05. Alright, from that we then can add 5 and 5 and we get R total equals 17.05 and that I total is 0.528. Alright, hopefully you guys can get there. Now I have to erase some of this because we're going to have to go over and do a lot more work here and go from there. So let me rewrite down, I'm going to erase all this and I'm going to rewrite down a couple of these things. Alright, so the first thing, I total equals 0.528, R total equals 17.05. Okay? Now, what do we know I total is equal to? A and G. So we know IA. Now, because we know IA and IG and we know RA and RG, we can find VA and VG. Again, they're the same because they have the same resistance. .28. Oops, half of that. 2.74, 2.64. Okay? And then together, so that's VA, VG, 2.64. Now, we also know from this right here that if we take V total, we subtract VA and VG, we get VE plus VF. So VE plus VF equals 9 minus 5.28, which again is 2.64 times 2 for both VA and VG. And that gives us 3.72. So, from there, we know that the change potential difference over this is 3.72. And since we know that the resistance over that whole bit is 15, we can find IE is going to be 3.72 over 15, or 0.248. Okay? And that's also equal to IF, because they're the same, right? We already know they're the same. Now, we also know that D plus F in current, okay, or D, words failing me here, B and C, which is equal to D, plus E is equal to the total. So, we know that then that ID is equal to 0.528 minus 0.248. And that gives us 0.28. Okay? Now, most of the way there, we've got the current for I and F, which means, of course, we can find the voltage over each of them if we wanted to. I won't take that last step right now. We also know D. So all we need left is B and C. Okay? And we know that the voltage of B and D equals E plus F. We know E plus F is 3.72. We also now know we can find VD minus ID times RD. Okay. And that's going to come out to be 0.92. Okay? Because ID is 0.28, RD is 10, so 2.8 right there. And then from there we can find, of course, that's also equal to VC, and from there we can find the currents fairly simply. Okay, a lot of work. Typically you won't have to find everything, but this is how you would find everything in a complicated circuits problem.